This session will be on Exchange ActiveSync and troubleshooting various issues that you may encounter. ActiveSync is a very popular protocol many people use today to view their email on their devices. And so, before we get into the troubleshooting, I just wanted to give a basic overview of ActiveSync and how the protocol works, so that when we go to troubleshoot, we have that better understanding and we know what we're looking for within the various logs. So on this slide, you can see a generic topology diagram where we have a device with the ActiveSync client. There's some network between the client and Exchange, and Exchange is the last piece, where we have the IS component, and we also have the mailbox store, and all the various Exchange components. And then any ActiveSync issue can be caused by any one of these three components. It could be a programmatic problem within the client itself. There could be network connectivity issues, and then there could also be issues within Exchange, whether the service becomes unavailable within IIS or the mailbox becomes unavailable, the database is down. And essentially all the communication from the client is secured by SSL by default. We use basic authentication, and the communication is WBXML, which is just a web-based, wireless-based XML to compress the traffic so that it's smaller. So after that, we want to talk about how the client initiates the session, and the device gets set up. So the first thing that the device and the client needs to do is it has to negotiate a version of the protocol to use. And that is done by using the options command. And in the response, it will provide a list of all the supported protocol versions and a list of supported commands. And here is an example response from the options command. And you can see on this line all the available commands available that the device can use, or the client. And here's a list of all the ActiveSync protocol versions. The client should use the highest version of the protocol that the server responds to that it can also use, which is this point in time is 14.1. Once the client has negotiated the version of the protocol, when you're first setting up the device, it needs to provision and create the profile. And creating the profile entails 6 different commands being sent by the device. The first is either a folder sync or a settings command, and that command will always fail with the device not provisioned response. And then the client will then send the provision command, and the first provision command gets the policy settings from the server. So any ActiveSync mailbox policy settings that have been configured server side are then sent to the client, and then in the second provision command sent by the client, it reports the policy status, whether or not it was able to implement those policies or not. And it also, in that response, will obtain a permanent policy key from Exchange. After the provisioning commands, it will send a folder sync command, and this allows the client to obtain the folder hierarchy. So this is where it gets the list of folders in the mailbox and associates the name with a folder ID or a collection ID, as you'll see in the logs here in a little bit. Once the client has the folder hierarchy, it then sends a sync command. And this is really important here, is the first sync command first sync command will then get a new sync key, and we'll send another sync command using that new sync key to retrieve the data. And we're going to talk a little bit more about this sync process here in a little bit. So what does an ActiveSync request look like? Each command is sent using a post, and it contains a request line, a request header, and a request body. And the request line and request header are dependent on the ES version. And there is a ActiveSync protocol document. When you look at the log, it's highly recommended you use this protocol document if you have any questions, and it'll guide you as to which command should use which elements and what goes with what. So here's a sample request, and here you can see the request line. The request line typically contains the user. So our user here is Stanley at Tailspin Toys, the device ID, the device type, and the command. Also in the request header, we'll see the authorization where we can see it's basic. And there's our protocol version. And you can actually see right below that is the policy key. And that would be that permanent policy key that Exchange sent. So if the policy changes, the client should then re-provision itself to get the new policy key, and you would notice that this policy key has changed. And we can also see in here the host that we're using to connect. Here's the request body. I'm just going to point out a few elements in here. Is the sync command, the sync key, and the collection ID. The collection ID is the folder. So if you remember when I mentioned the initial folder sync gets the folder hierarchy, we'll never see a folder name in the logs. We'll always see this collection ID value. And an ActiveSync response follows the same format as the request. We'll have a status line, which contains the HTTP version and status code. We'll have the response header and message body. Not all commands are going to have a full message body, such as the send mail. The send mail is going to just get an HTTP response, the status OK. So here's the response header where we could see the version and the 200 OK, and down in the entity you can see the content length and content type. Here is the response body. So this is the response that sync request that I showed earlier. Here we can see the new sync key the server sent. There's also the collection ID, and this is the EAS status. So with ActiveSync we have IIS status codes, which tell us whether there's an issue within IIS, and we also have ActiveSync status codes. Is there an error within the protocol? And each command has its own status codes, and then there's a list of common status codes. And I'm going to show examples of all those here in a couple of slides. And so in this response, the server was sending an ad to the client, and we could see the ID of the item, so we don't actually know which item it is. And then in there, this is taken from, this is not a mailbox log, this is captured from Fiddler, so we can see the details of the to from subject. When we go to look at the mailbox logs in a little bit, you won't have all this detail. And since this is an email message, it's important to note that the conversation ID and the conversation index values that I highlight at the bottom, that's how we can identify a message within a mailbox log and correspond it to the actual message in Outlook. Typically with email, this isn't as important because they know the subject, they know what's wrong, what's missing. But if you didn't know it, this is how you would link the two. So here's a table of some of the common HTTP status codes. The 200 OK. And if we see that, that just means we didn't encounter any errors in IIS. Remember, there's still that ActiveSync status code, so there could have been a protocol error. There's the 403 forbidden. It's an HTTP status code, but if you disable a user from ActiveSync, that is the status code that you'll see. The 451 redirect we no longer do with Exchange 2013 or in the Office 365, so you shouldn't see that. And then there's the others, 500 error codes. For the ActiveSync status codes, this table shows you the status codes for a sync command, since that was the example I showed earlier. So here you can see 1 is a success. So that response body that I showed earlier was a success. A 3 would be an invalid synchronization key. We see this a lot with those resyncs. So if a server response includes a status code of 3, the device needs to send a sync key of 0 in the next request. And then there's a few others, the 4, 12, and 16 as a retry. And along with these status codes for the command itself, there's also the common status codes. So every ActiveSync command that is sent could receive a response with these status codes. And some of the common ones are the 142, the device not provisioned, when first setting it up, the policy refresh, and invalid policy key. Now I want to talk a little bit more about the hanging commands, how a device gets new items on it. So there's two ways a device gets it. It either sends a hanging sync command or a hanging ping command. The hanging sync command synchronizes all the changes on a folder between the client and server. So it sends the request, sync request to the server with a heartbeat interval, and it sits on the server for that length of time unless a new item appears in that specified folder inside that heartbeat interval. If a new item is received in the folder, it'll respond with the new item in the response. And it'll also include a new synchronization key that should be included in the next request. This is different from a ping command, in that a hanging ping command just monitors the folder for changes. So once again, it sends the command to the server and it sits in memory waiting for a new item in the folder. When a new item appears in the folder with a ping command, it's just going to send back a response to inform the client that there are changes, and then the client needs to send a sync command to retrieve that item. The iOS devices and Windows Mail on Windows 8, they use the ping commands, and then other devices, Android, BlackBerry, and Windows Phone, they all use the hanging syncs. So just to show this in a little more detail, here's an example request body, and we're sending the request for the collection ID of 5. You can see the sync key is 1, 2, 3, 4, 5, 6, 7, 8. The server response will include a new sync key. This time it's 98745432. The client should then use that sync key in the next request, as you can see here. But what happens if the client does not receive the response from the server? So what I mean by that is the client sent that first sync key, the server sent a response, but there was some network issue, and the client didn't actually receive the response, but Exchange sent it and think the client received it. Well, what can happen? In this scenario, the client should resend the original sync key. So there's only two valid sync keys that a client can send. It's the current sync key and the sync key in the current response. And we allow this just for this reason. So if there's any kind of network connectivity issues, it gives the client a chance to re-request the information, because the server doesn't know if the client received the response. The same thing is if the client sent it but it never made it to the server, the client needs to be able to send that same sync key. And when it does this recovery sync, the sync key, if the server received the first request and sent a response, and then the client sends the same sync key a second time, the sync key from that first response becomes invalid. A little confusing, but we're going to do a demo where you're going to see this. So here's a graphical representation. The request 1, sync key of 100,001, the response is 2. Client sends 100,001 again, gets 100,003. It should then send 100,003 and then gets another response. That 100,002 is invalid. It should never send that sync key. Even if it does receive it, it has become invalid. So we also want to talk about the synchronization state. So at a mailbox level, each folder is identified by its unique collection ID value, and each folder has its own unique sync key to manage its synchronization state. So you should never see collection ID 5 sending a sync key of 1 and also a collection ID of 3 sending a sync key of 1. Very rarely would you ever see that. That would take extreme circumstances to ever have the same sync keys. They have unique sync keys. And all items within the mailbox, whether it's a calendar item or an email item, they all are identified by the server ID value. And then for email items, as I mentioned earlier, each email item has a unique conversation ID and index ID. And that's how we can identify within the logs. Attachments within an email item are stored in an attachment table, and when we see them in device logs, we'll actually see them as the server ID value colon and an attachment ID value. And if you use something like MFC Mappy to view the attachment table, the ID within the mailbox log would match the ID within the attachment table. For calendar items, as we all know, calendaring is the biggest issue we have in ActiveSync. For calendaring, each item has a unique global object identifier. So anytime a new appointment or meeting is created within a calendar, it's assigned a unique global object identifier. This never changes. Whether you change the subject, you add an instance of a recurring, you change recurring, you delete, it never changes. When you do make changes to a meeting, those changes are stored as exceptions in a separate table for the calendar item. And then the start time specifies the start time on the calendar item in UTC. So I bring this up because when we look at logs, you'll see when there's exceptions, there'll be an exception start time and a start time. The start time is always the start time for the appointment. The exception start time will be the original start time. Here's a table of some of the common command elements that we're going to see in the logs. Include the collection ID, sync key, the server ID. We've already talked about most of these. The window size just specifies how many items the server can send back in a response. And if that the server has a response that includes a greater number of items than the window size allows, you'll see that more available. So now let's get into the troubleshooting. Traditionally, from the on-premise days, we love to use the IS logs because it's enabled by default. It has the historical data, so whenever we have an issue with anything HTTP related, we would go to the IS logs. We could filter those IS logs based on the virtual directory. So for ActiveSync, we can filter it on the Microsoft-Server ActiveSync virtual directory, and we can try to figure out what happened using the IS logs. And one of the key elements in those logs for identifying issues were the date, time, the CSURI query, the status, and time taken. So I have a sample IS log here, and here we can see the date, time, the user, the device ID. We can see the command that the device sent, or the client, the folder count, so this sync command is for one folder, the folder ID, this is the collection, so it's 5. The type, this is one way we could identify calendar or contacts. And there's the sync key, and here, what's highlighted now tells us that the server sent one add back to the client. And the status of 1, so we know it's a success, and the HTTP status code of 200. So we get a lot of information from an IIS log. But what item was added? When we go back and look at that log, it told us one item was added. What if it said one item was deleted? We don't have details within the IS logs to give us that granular information. So we can make assumptions using IS logs, but we don't want to do that. We need definitive answers when it comes to ActiveSync. So for troubleshooting ActiveSync, we use the ActiveSync mailbox log. And to enable this, it is enabled server-side by default, it just needs to be enabled for the mailbox. And we can do this through either the remote shell or through the OA Exchange Control Panel. The one downside with the mailbox logging is that you must be able to reproduce the issue with logging enabled. Unless you've turned on logging ahead of time, which is not normally the case, it's not historical. It's only from when you turn it on until you retrieve it that you have the data. So from the shell, it's just the set-cas mailbox commandlet with the -activesync debug logging, setting that to true. And then from OA or through the ECP, if you go to the phone section and under mobile devices, you can highlight a device and click on the Start Logging button. And when you do that, it's going to prompt you with this little warning. You could just say yes, and then the logging will be enabled. To collect the log, you can collect it the same way you enabled it, either through the shell or through ECP. To retrieve it from the PowerShell, it is get-activesync device statistics, or now it's get-mobile device statistics. Either one will work. And then you specify the mailbox, the get-mailbox log. And then if you use the -notification email address, it'll email it to that recipient. And then the rest of this commandlet makes it so it's in a good format for the tool that I'm about to talk about, Mailbox Log Parser. And then the out-file just prevents it from scrolling on the screen. And then through ECP, same place you enabled it. When you enable it, that button actually just changes to a retrieve log button. This is mailbox level, so it doesn't matter which device you select. When you hit Start Logging and Retrieve Log, it's going to turn it on for the mailbox, and then it's going to retrieve logs for every device that user has. And when you do it through the ECP, it's going to email it directly to the user. So for the log analysis, we can use any text editor, or we have a tool, the Mailbox Log Parser, that is designed to analyze these mailbox logs. And as I mentioned earlier, it's very critical that we have the ActiveSync protocol document as a reference for whenever we get stuck. We want to know, okay, why did it do that, or what's that status code? Having that document readily available really helps to troubleshoot the issue. So here's a sample mailbox log, and this is just a truncated version of one. And you can see in here we have the log entry number, the request line, we can see the sync key, the collection ID, and this is just one. So imagine if you turned on the logging and it took a couple of days. You could have a couple of thousand log entries. If you're looking at this through a text editor, it can be very cumbersome and difficult to find out what exactly happened. And that's why this Mailbox Log Parser tool was created. So just to give you a brief overview of how to use the tool, there's the import mailbox logs to grid. This is how you add a log to view. The clear grid will remove the log from this tool, and then we can search the log for text with the search dialog box. Anytime you do a search and you want to start a new search, you need to hit clear to clear the original search. Otherwise, it will search within the existing content. When you open up a mailbox log in here, you will see several columns, including the name, which is just the log entry ID, the server name. This is the server that processed the request. We have the user mailbox, the command the client sent to Exchange. We have the request time. This is the time Exchange received the request, and the response time is the time Exchange responded. So if there's any kind of network latency or connectivity issues, client may have sent it sooner, but it may have taken a few minutes or a few seconds for it to actually reach Exchange. There's also the HTTP status, what happened in IIS, and the status column for the ES status. And then there's also the status definition. So for some of the statuses, we have them hard-coded to actually provide the definition there. If there's any exception, it'll display the exception info here. And then these round trip seconds, it's just doing the calculation based on the request and response time. And then we can see the protocol version, and if there's any ABQ, allowed block quarantine, any policies in place to prevent devices from connecting, there's the access state and the access state reason. You can get all that from the mailbox log. And then on the far right hand side of the tool, which you'll see here very shortly, it will have that one log entry filtered, so you can just view the one log entry. So now I want to go ahead and go through a couple of sample scenarios and how we can identify these using these ActiveSync mailbox logs. So the first one, we're going to do some calendaring issues. So with that, I'm going to go ahead and bounce over to my virtual machine. And here you can see my user's calendar. And the first one we're going to talk about is where an instance of an appointment disappears from the device. So here, looking at this user's calendar, we can see he has an appointment at 2 p.m. on Wednesday and Thursday, the 21st and 22nd. And he sent an email stating that he doesn't see the appointment on the 21st. And he took a screenshot from his device, and we can certainly see that that item is missing. So the first step is, if you remember, the mailbox logging is not verbose. It won't show us the subject. So we need to identify this calendar item within the mailbox log. So to do that, we can use MFC Mappy to open up the user's mailbox and open up the calendar. So once you have MFC Mappy, just double click on the mailbox, expand the root container, expand top of information store, and then right click on the calendar and open contents table. And I'm going to go ahead and maximize this. And then we can find the appointment by using the subject. Here I can see demo add attendee. And what I want to get out of here is that GoID value. That is the unique identifier for the appointment. And that attribute is right here. And you can see under the named property name column, the PID lid clean global object ID. So I can just double click on this value and copy my GoID. So now I've already retrieved the mailbox log, and I have mailbox log parser running here. So I'll import the mailbox log to the grid and choose my mailbox log. Here you can see, just like we saw in the slides, all the columns and all the information. So for calendaring issues, we already have the GoID, but if you wanted to do a quick search for anything calendaring related, you can just type UID here in the search string and search for UID. UID is the GoID values in a mailbox log. So now you can see we filtered 863 rows and we can only see 16. So I'm going to go ahead and clear this so we can troubleshoot this issue in particular, and I'm going to paste the GoID value. And here I can see I have one line. There's only one request and one response for this item, and I can scroll down here and I can see that there's a change for server ID 17, and there's the UID that matches what we did. And here you can see there's no detailed information, but we can see the start time and end time. So here's the start time. This is the 22nd, and it was the 21st that was missing. So I accidentally grabbed the wrong GoID from the MFC Mappy. So I'm just going to jump back. I should have looked at the start date. So we'll go ahead and grab the GoID from this one. You can go through here and find the start time as well in the Mappy properties. And let's go ahead and clear this and paste that one. Did not change it. All right. This one is the 21st. clear. Sorry about that. Let's see. All right, so it's still on this one where it's saying a change. And it's the 22nd. Oh, I'm sorry. This is the, that's why I missed it. This is the request. So we're sending a change for server ID 17. I wasn't paying attention. And then here's our response. So if we look at these last characters, BBD5A2, there they are. This other one up here is also BBD52. So both of them are the same. So we're doing an add for 1.8 and an add for 1.9, and they both end with the same ID. We really need to go through and look at all the values, and if you look somewhere in the middle here is the start time difference, but here we can also see the start time is 5:21. So this is the appointment we're after, is this 1.8, and it was doing an add. So we did an add for this item, but it's not on the device. This 1.9 is a different appointment for the 22nd. So the question becomes, okay, well, we sent an add. What happened? With calendaring items and mail items, we do not send anything but this server ID for a delete. So we can also copy this and just search the log real quick to see everything with this server ID value. So now that we see only this one entry, we've confirmed that there's no delete. So from an exchange perspective, the server sent an add for this calendar item, so this calendar item should be on the device. So either the device didn't receive it, or it received it and didn't process it properly. And we can see here, this is log entry number 291. So if I clear my results and just filter this now on collection ID 1, and do a search, I can see additional sync commands for this folder. More importantly, in this response, I can see I got the new sync key 33145, and the next sync request, excuse me, contains that new sync key. So the client did get this response. So for some reason, this client didn't process this calendar item. So we would need to get device-side logs from the actual device and work with the OEM to figure out what happened with this calendar item. So I'm going to go ahead and clear these search results. And the second demo is a little bit more complicated. So for this one, I'm going to cancel out of there, just minimize that. If we look at the user's calendar, you can see every day this week, excuse me, he has an appointment that starts at 9 a.m. except for Tuesday. It was bumped back 2 hours. And he's reporting that on his device that didn't change. So once again, he sent us a screenshot just so you can see that sure enough, this appointment is showing on his device as 9 a.m. every day. For some reason, the device didn't get that updated change. So we can go to MFC MAPI once again, and this one is the demo recurring resource issue, and we can go ahead and get the global object ID for this appointment. Having that value makes searching these mailbox logs very easy. And I'll go ahead and clear this, make sure it's brand new, and I'll search for that GoIt. So in this example, we can see we now have 5 entries for this calendar item. And it starts with this sync request, and if we scroll down to the response body, we can see it doing an add for server ID 11. And if we look, we can see the start time is 1300, which would be 9 a.m. And we can see the recurrence pattern here. So we know that this is the recurring meeting. The type of 0 is it is daily. The interval is every day for 20 occurrences. And we can get all this from the protocol documents. Busy status of 2, meaning that they're busy. The meeting status of 1, stating that they are the organizer. So we can get a lot of good information from this log entry. So we know we sent the ad to the device. So let's take a quick look at log entry number 2. And here we can see that there is a change for our server ID 11. And if we look here, here's an exception. Our first exception. And this is a delete. So we deleted an instance, 526. So just curious, I'd ask my user, did that appointment disappear from the 26th? We can go back to his calendar, look here. It is gone from here, and it was gone from the device. So that exception processed properly. And that is the only change for this appointment. So not related to the issue for the 20th. So we can look at the next log entry for this calendar item. And if we scroll down to the response body, once again, we can see this one has a change. Server ID is 11. So this is the same appointment. And now we can see an exception for the 20th. And if you notice here, the start time is still 9 a.m., 1300 Zulu. So there's no change in this one. This is still the original start time. There's no change in subject or anything. So no real changes were sent in this exception. So if we look at the next log entry, and we look at the response body, it's once again a change. So the server will either send an add, change, or delete. And so as we go through these, we want to keep track of what's happening, whether it was an add, change, and delete. So here's another change. Here's that second exception again. And this time, notice the start time did change. This time it's 1500 or 11 a.m., which matches what we see in the user's Outlook calendar. So the question now becomes, okay, well, did it receive this response and did it process it? And we can see here there's a later 448 is another sync request. So it was still sending requests afterwards, but why did it not make this change on the device? For this issue, we had to dig really deep. And if you look at the exception start time, this DT stamp is the change timestamp, last modified. And we can see that that was at approximately 8 o'clock on the 15th. If we go back and we look at the previous one that had that second exception, this one was at 8:04, 4 minutes later. So based on this, it would look like the device is going by the timestamp. And since this response has a newer timestamp, a newer last modified, it appears to be ignoring this second response that has the actual change. We've done a lot of investigation on this issue, and it's been determined that for this specific issue, the DT stamp should not be the determining timestamp. The actual sync state of the folder trumps any last modified timestamps. So those are our two countering issues. And here I provided a couple of tables with some of the elements that we see within the mailbox log. So the busy status, the meeting status. The meeting status is critical for any kind of organizer hijack scenarios that we've seen in the past. There's been significant progress in preventing these from both the exchange perspective as well as the various clients. But typically with the organizer hijack, you would see the meeting status value change from a 3 in a mailbox log to a 1. And whenever we see that in a mailbox log, we know that at that point in time, a hijack has occurred. And then also the response type. So when a user responds to a meeting request, these are the typical values we would see in the mailbox log. So the second issue, the second demo I want to demonstrate is that resync, because this is very common with both iOS devices and Androids, and we even see it with Windows Phone. And the reason we see most of them is network issues, and I'm going to demonstrate why. Oops, sorry about that. Let's go back to our mailbox log. Earlier in the presentation, I mentioned that a sync key of 0 is when we're initializing the folder, and that is also when we would see a resync. So in the search field, we can do a sync key greater than 0, and I'm just going to show you here. So when we send the request, this is the sync key element. I'm just going to make it short and just add sync key greater than 0 rather than type the whole thing out. And now I've filtered the log for all the requests that send a sync key of 0. And here we can see some folder syncs. We can ignore those. Those aren't going to be a resync. Those are going to be the folder hierarchy syncs. And this log had a provision occur in the middle, and that's right here. We can see that status 144 invalid policy key. So I'm going to skip everything ahead of that. And we can just look at right here at starting at 339. So at 339, we see a bunch of sync key zeros, and if we look over here at the request, the collection ID is changing. And that's because we're doing the initial sync for each of these folders. And then at 354, this is 15 minutes later, we can see a sync key of 0 again for this collection ID. So the user did report it happened around 4, and he stated that it also happened right around 4:30. So we can see it happened again here at 4:22. So what I'm going to do now is first take this one at 354. And I'm going to take this collection ID, and I'm going to change my filter for just that collection ID. And I'm going to make note of this log entry 249 and hit search. Okay, so now in the log I can scroll down to 249. And here we could see that request. And right above it, we have that status of 3, that invalid sync key. And when we looked at the protocol doc and we looked at those status codes, the client was supposed to send a sync key of 0 when it receives that status code. So the client is behaving as expected. So the question becomes, why did we send back a status code of 3? So since it's a sync key issue, we can just focus on the sync keys in the requests and responses. So for this request that resulted in the error, it ended in 8435. So if I go back one previous request, I can see the sync key of 220, and the response was 2207. So knowing the sync process, that next request should have sent the sync key of 72207. If we go back one more, we can see that 86220 again. So the client actually performed a recovery sync. And if we scroll down at the response, there's that sync key of 8435. So in this scenario, the client sent the request. There was some network connectivity issue that caused the problem with the response being back to the client timely. So it actually sends the second request with the same sync key. And while it's sending that request, it gets the response back from the first and then sends another sync request using the new sync key it received. But this exchange has received the second request, the recovery sync, so it's invalidated that sync key, so it cannot use it, and when it does, it receives that status code of 3. So that's an explanation of that scenario of a resync. But he said it also happened around 4:30, and we saw that sync key is 0 at 4:22. And here it is. I have it highlighted. This is log entry 415. You see in the request once again a 0 for collection ID of 5. But notice here, HTTP status codes are all 200 and EAS status codes are all 1. There were no errors reported by Exchange. for this client before it sent the sync key 0. So it would appear that this device resynced on its own. And how can we determine how that happened? That leads me back to PowerPoint and the use of Fiddler with ActiveSync. So if anybody's used Fiddler for any other HTTP traffic, we can also use it for ActiveSync. And Fiddler just acts as an HTTP proxy, and it allows us to decrypt HTTPS traffic, which allows us to view the requests and responses. EAS Inspector was written for Fiddler that will decode the WBXML, so we can see the request and response bodies decoded within the response. And this allows us to see the request as it left the client and as it comes into the client. So this is the last hop. So if anything altered the response between the exchange and the client, we would see it here within the Fiddler trace. And to do this, we need to have the client or the device and a workstation on the same network. So putting the device on a wireless network, and then any workstation can have Fiddler installed, and then we can configure Fiddler. And here I have a couple of slides. So within the Fiddler, there's the tools and options, and you'll go to the HTTPS tab, and you'll just select the option to decrypt HTTPS traffic, and then under the connections tab, you just check the box to allow remote computers to connect. And I believe it does require a restart of Fiddler for it to start acting as that proxy. Then from a client perspective, when you go to the Wi-Fi settings, you can modify the network settings to allow it to use a proxy server. So I took screenshots here. You can see when we edit the network where you can add the proxy on a Windows Phone device and also on an iOS device. So you just highlight the Wi-Fi connection, and then there's a little I think it's an I button on there. You just click on that for the information, and you can just set the proxy to manual. And once you do that, the workstation will be capturing the data. And so for that second issue, I just want to go ahead and we didn't see anything in the IS logs, but I did capture a Fiddler trace at that time. And so here it opened it up right to the bottom. And one easy thing to do is you can click on the Find and just type ActiveSync to highlight only ActiveSync traffic. And this was a long-running trace, so it would be hard to find it. But I know, and it's common knowledge now that Apple has released, if an Apple device receives 2 consecutive 500 errors or multiple 500 errors, it will do a resync. So I can take a look at my status column, my HTTP status column within Fiddler, and I can look to see if there were any 500 errors within this trace. Is there anything that would give a hint that there was some kind of network issue or some network device between that maybe threw the error? And if I scroll down far enough, here we can see a 500 and a 503. So this didn't do it because here's another sync. So if I go here, I don't have the ES Inspector now on this box. But here I can see multiple 500 errors repeatedly occurring. So I know that resync occurred because this client was receiving 500 errors. And if I look at the headers in the response, I can see the remote server has paused or is in the process of being started. So there's some device between Exchange and my client that went into this pause state that prevented the traffic from reaching Exchange, causing these 500 errors, ultimately leading to the device to do the resync. Demo 3. That was the second resync. So here are some links for the tools, the Mailbox Log parser, where you can get Fiddler, the inspector for Fiddler, and MSE Mappy. And I've also provided some resources, a link to the protocol documents, so you can use that as a reference. And there's also been blog posts on analyzing mailbox logs on the EHLO blog. And with that, bring it back to Heather.